Hello everyone and welcome back to Exam Ignite channel. This is fifth semester digital communication subject of code BEC503 and this is the module 3 video continuing the series that we had started. This module is all about the information theory. In the information theory, we'll be learning about entropy and source coding theorem, lossless data compression algorithms, discrete memoryless channels, mutual information derivation and its properties, channel capacity of the binary symmetric channel, channel coding theorem, information capacity law, only the statements. So here this I had prepared using the model question paper and last two previous year papers. One is June, July 2025 and December, Jan 2025. So these were some of the problems that had been asked in those papers. So we will get through this module and finish all the topics. Starting with the first part, that is entropy. The entropy of a discrete entropy is the discrete random variable representing output of the source information. It's a measure, or it is, you can say it is a measure of the average information content per source symbol. So this is what entropy is. To write a neat definition, you can also write it as it is an average information content of the symbol in long independent sequences is called entropy. So average information, it is a total information divided by number of messages. That is equal to what? I total by L. So here you can say it is represented as entropy is represented as H. So you can say H is equal to I total by L. So next, what is the total information then? What will be the I total? It is P1 into L logarithm functions we are using here. Log of 1 by P1, then P2 L log 2 of 1 by P2 till Pm L log 2 of 1 by Pm. So you can write H into replacing the I total. By L, you can replace and write the H. So my H of S is equal to summation of K is equal to 0 to K minus 1 Pk log 2 of 1 by Pk. So also you can derive this directly by writing H of S is equal to E of I of S, Sk, and that can be expanded as summation of K is equal to 0 to K minus 1 Pk I Sk, and this I Sk can be written as log function. So this is what you have to write. This is an important question. You need to write the definition properly. The average information content of symbols in the long independent sequence is called as an entropy. So it is a discrete random variable representing the output of the source information. It is a measure of average information content per source symbol. So coming to the properties of entropy, the first property we are learning here is entropy will be 0 if the event is sure or impossible. That is H of S is 0 at that time when it is sure, or you can say it is impossible. Next is when Pk is equal to 1 by M for all the M symbols, then the symbol that are equally likely for such source entropy. So that is given as H is equal to log 2 M. So next is upper bound of the entropy. It is given as H maximum. This will be asked in the problems. So to find the H maximum at that time, you need to use the formula H max is log 2 M bits per symbol. Next, entropy is a continued function of probability. Entropy is a symmetric function of its arguments. These are the 5 properties you need to write. So next is before going to the source coding theorem, we will move to some problems regarding the source efficiency. So it is an information source that is defined as the ratio of the average information conveyed by the source to that of the maximum average information. It is given as ns is equal to h of s divided by h maximum into 100%. This gives the source efficiency. The redundancy of the source is defined as what? This is minus by 1. So RNS is equal to 1 minus NS. That is equal to 1 minus this H of S by H of S max. So you can write like this. Now let us consider a problem. Here a binary emitting two symbols with a probability of 0.6 and 0.4. We need to find the information conveyed by the bit 0 and 1. So Ik is equal to log 2 of 1 by pk. We know this formula. So applying to this formula 0 and 1, we get 1 by 0.6, log 2 of 1 by 0.6, and log 2 of 1 by 0.4. So these two are the required answer. Next is a pair of dice is rolled simultaneously. The output of the first dice is considered as X and the second one is considered as Y. So the events are given as P is equal to XY such that X plus Y is exactly divisible by 3. Then Q is XY such that X plus Y is exactly an even number. Next XY such that X plus Y is 7. So these are the three conditions they have given. Which event conveys more information? Justify your answer with mathematical calculation. So here first you need to find the set of sample space and events for all the PQR. So this is our S, that is if the dice is rolled, two dice are rolled, this is all the probable outcomes that we will be getting. So next is P. So for P, what they said, the adding of two numbers that should be divisible by 3. That is what you have to take out of the sample space. And similarly for the Q and R, you need to write down. For that, finally, the P of probability of the P occurrences, how many sample spaces are there here? We are having 12. So 12 divided by overall is 36. So it is 12 by 36. This is 18 by 36 and it is 6 by 36. So you need to justify here as the probability of occurrence of the event is less, it conveys more information. R is less means more info. IK, we need to find out IP, IQ, IR similarly. So 1 by 12 by 36, 1 by 18 by 36, 1 by 6 by 36. So hence we get 1.5, 1 and 2.6. So out of this, which will convey the more, as it is more having greater value compared to all, this will convey the more information. Next is a discrete memoryless source emits 5 symbols in every 2 milliseconds. The symbol probabilities are given as like this. You need to find the average information, that is rate of source. That is nothing but they are indirectly saying you need to find the entropy. So entropy's formula is given like this: H of S is equal to summation of K is equal to 1 to N. What is the N value here? It is 5. Next, pk log to 1 by pk bits per symbol. So you need to substitute 1 to 5. So what is the value of 1 here? It is 0.5. So 0.5 log to 1 by 0.5. Similarly for all the other values, you need to add them by taking the, first you have to solve them in the calci, solve it and then multiply it with 0.5. Each of them you need to add and you will be getting H of S as 1.875 bits per symbol. So then you need to find the average rate of information. So that is given by what? RS. RS is H of S into RS. The rate is rate of, here you can say the small r is the symbol rate. So in this problem it is given as 2 milliseconds. So for the what the value you have got, for that you need to multiply it with 2 milliseconds. So before multiplying it, you need to convert it into the seconds. So symbols per second, multiply it with 10 power minus 3, you get it, and multiply that and this to get the average rate of information. Next is the output of the information source is given as 160 symbols and 120 of which occur with a probability of 1 by 256 and remaining with a probability of 1 by 64. Find the average information rate of the source if the source emits 10,000 symbols per second. So as same, you need to find the entropy. Use this equation H of S. Using that, solve for 128 and for 128 and for 32, then you will be getting the answer as, you need to add 32 to that and another one is 64. And finally RS, you need to multiply it with the 10,000 for the obtained value, that is 7 into 10,000. Next is the important question. This is a model question paper question, the Morse code. So that is given as, it was a sequence of symbols of dots and dashes to transmit the letters of English alphabet. The dash is represented by a current pulse of duration 2 milliseconds and dot is represented by duration of 1 millisecond. The probability of the dash is half that of the dot. So consider 1 millisecond has a gap between the symbols. You need to find the self information of the dot and dash, average information content of the dot dash code, average rate of information. So to find this, first you need, as they have said, dash is equal to half that of the probability of dot. So both of them, adding both of them, we get it as 1. So you can write P dot plus half times, substitute it, half times the P dot is equal to 1. So P dot probability is 2 by 3. So similarly, for P dash it is 1 by 2 and P dot it is 1 by 3. So we have this given. Now I dot you need to find. So I dot is log 2 of 1 by dot, that is 1 by 2 by 3. You get this as answer. Similarly 1 by 1 by 3. You get this as answer. Now H of S, you need to find the entropy. For that, apply the value P dot value what we had got and 1 by P dot, then P dash into 1 by log function of 1 by P dash, you will get this answer. So this is one part is done. Next is from the probability of the dash and dot, it is clear that every 3 symbols transmitted, there will be 1 symbol of type dash and 2 of type dot. So also the duration of dash is 2 milliseconds and the duration of dot is 1 milliseconds, and 1 milliseconds gap is left between the symbols as follows. So it is like 2 dot 1 dash, 2 dot 1 dash, 2 dot 1 dash. So totally you can say 1 milliseconds, 1 milliseconds, 1 milliseconds, 1 milliseconds. Here you can observe 2 and 1. Finally, we are having 7 milliseconds time is required to transmit these 3 symbols. So the symbol rate, you need to find out the symbol rate, that is given as RS is equal to 3 by 7 symbols per millisecond, and converting that to the seconds, it is 300 by 7 symbols per second. RSS, you need to multiply this rate, to that obtained entropy. So entropy into this rate is, we got bits per second. Next question is, consider a system emitting one of the 3 symbols, that is ABC, with the respective probabilities 0.7, 0.15, 0.15. You need to calculate the efficiency and the redundancy. Efficiency, we know it is given by this formula. To find out this, we need the H of S. So find out the H of S using the entropy formula with all the 3 probabilities that they have given. After finding that, the next formula you need to know is H of S max, that is log 2 of n. What is n here? N is 3 probability values. So log 2 of 3 is 1.5, what we have got here. So now efficiency is, divide this by this, into 100%, you get the efficiency as 74.52%. Redundancy, again need to know this formula, RNS is equal to 1 by NS, that is 2.48% is the redundancy. This type of questions you can expect, you need to know these 3-4 formulas. Next is, in a first-line transmission of a picture, there is a 4 into 10 power 6 pixels per frame. For a good reconstruction of the image, at least 8 brightness levels are necessary. Assuming all the levels are equally likely to occur, find the average information rate in one picture is transmitted every 4 seconds. Total they have given, and the total number of brightness level is also given. Therefore, what is the total number of different frames? That is equal to n. That is given by 8 power 4 into 10 power 6. So as all the brightness level are equally likely to occur, all these frames are equiprobable. So what you can say, H max is given by H. These two are equal. That is equal to log 2 n. N is 8 into 10, 8 power 10 into 10 power 6 into 4. So that is gives the bits per frame. Entropy, you need to find the RS. So RS is, you need to know the small rs. It is given that it is 1 by 4 frames per second. So multiply this to the obtained entropy, you will be getting the RS. Next is, consider a zero memory source emitting the symbols X, Y, Z respectively with a probability of 0.6, 0.3, 0.4. You need to calculate the entropy. All the symbols and the corresponding probabilities of the second order extension of the source. Find the entropy of the second order extension and show that H of S square is equal to 2 into H square. This is one of the important questions. So every year it's been appearing. So they just change the values of these probabilities. Either they give them in the fraction form, usually 1 by 2, 1 by 4 and 1 by 4, like that. So they change this, and this is the one common thing that you need to prove always. So first you need to start finding the entropy formula. Our n is equal to 3, apply it 0.6, 0.3 and 0.1, you will get the entropy bits per second. So finally consider the second order extension, that is you need to make the symbols of xx, xy, then xz. Next comes yx, yy, yz. as 3 sets, make them as 3 sets. And the probability, how do you find the probability? Px into Px. What is the Px value? 0.6 into 0.6, that is 0.36. Again, you get the values in the set of 3. After finding this, now you need to find the h of s square. That is equal to what? How many probabilities are there here? 9. So our n is equal to 9. Pk log to 1 by pk bits per symbol. Again, entropy formula. So apply this formula to these values. You will be getting the answer as 2.509 bits per symbol. For that, you just multiply for the h of s what you have got, what you had got previously. That is this value. For that, you just multiply 2. You will get the same answer. So this proves that h of s is s square is equal to 2 times h of s. So this is how you have to prove this. This is an important problem. Please do note this. Next is a binary source is emitting an independent sequence of zeros and ones with a probability of p and 1 minus p respectively. You need to plot the entropy of the source versus the probability p. So this is an important question that had been asked in the July, that is June-July 2025 paper. So let us see the answer. H of s, the entropy formula. For that, what one you consider it as P1, another one you consider it as P2. P1 is given as P only and P2 is given as 1 minus P. So let us consider now, let us consider P as, so let us consider the P as 0 0.1, 0 0.2, 0 0.3, 0 0.4 like that. So for these values, what do we get as P? If we consider P as 0 0.1, then 1 minus P as 0 0.9, you get these values. So similarly, do it for 0 0.2, 0 0.3, 0 0.4, 0 0.5. So on summarizing that, for P is equal to 0 and P is equal to 1, H of S is 0. Write down the values for that. If P is 0 0.1, what do you get? H of S as still 1. So we entropy values for the various probabilities. Now plot the graph H of S versus P they have asked for. So here you can observe when it is both are 0, this is the point first we get. Next is P is 0 0.1. For 0 0.1 it is 0 0.4. It goes on increasing 0 0.7, 0 0.8 like that. It goes on increasing and then it reaches 1. Here it reaches 1 for the 0.5 value of P. And finally, it again starts decreasing. Again, we get 0.9, 0.8, 0.7, 0.4, and finally 0 for 1. This is how you need to plot the graph. So next we will move on to the source coding theorem. Source coding theorem, you need to write a block saying information source is sent as SI to the source encoder, and that gives us BI. A source coding process of assigning a minimum length digital sequence to each of the information symbol emitted by the source. It is like a code word that can be fixed or variable length. It can be of any length. So basically that source coder, it has to satisfy the two requirements. One is if it is a shorter code word, then the frequency source symbol. If it is a long code word, it is a rare source symbol. Do not I use S bar B as symbol. Now the code words produced by the encoder in the binary form. Now, as usual, now source code is uniquely decodable so that the original source sequence can be reconstructed perfectly from the encoded binary sequence. So next we will start here. One is average code word length. We need to find out the average code that is represented by L bar. It is summation of k is equal to 0 to k minus 1 pk into lk. What is code efficiency? It is L minimum divided by L. What is this L minimum? This is the minimum possible values of the L. This is given by Dashinon's first theorem. We can get this L minimum. So you can say given discrete, if it is a discrete memoryless source, when the output is denoted by random variable s, the entropy h of s imposes the following bound on the average code word length for any of the given source coding scheme. So what becomes L bar is will become greater than or equal to h of s. So our efficiency will be h of s by L bar. So next topic is lossless data compression algorithm. So for a efficient signal transmission, the redundant information be removed from the signal prior to the transmission. So that is itself called as lossless data compression. It is classified based on this application as lossy as well as lossless. Lossy means you can observe it in the video conferences or in the personal communication where we can tolerate certain loss of the information. But in the military or the medical, we cannot compromise in the loss. We demand utmost reliability in the transmission. So how can this be done? So prefixing code, this is the first, this is instantaneous code. This is defined as a code in which no code word is a prefix of any other code word. You cannot repeat it. Once the code word is done, in the prefix, you cannot repeat that in the future code words. So let us illustrate an example to explain the prefix code neatly. So we are having source symbol as like this, and the probability of their occurrence is just an example. And let me code it then. In the code 1, I'll be coding as 0. For this it has 1. For this it is 0, 0 and 1, 1. Here 0, 1, 0, 1, 1, 0, 1, 1, 1. Here 0, 0, 1, 0, 1, 1, 0, 1, 1, 1. What happens in the code 1? Let me consider the code 1. Here S0 is having the prefix of S2. So S0 is what? 0. So here again the 0 is getting repeated in the S2. Again in S1 we are having 1, and here in the S3 it is having a prefix of that S1. So this is an invalid code. Now let's consider the code 2. Here what happens? 0. It is not repeated in any of them. Then 1, 0. There is no 1, 0 repeated again. Next 1, 1, 0. It's not repeated. So no code word starts with the another code word. So this is a valid code. Coming to the last one, you can observe here 0. Here again 0 is repeated. 0, 1 again here 0, 1 is repeated. 0, 1, 1 here also 0, 1, 1 is repeated. So the prefix is being repeated. So you can say this is an invalid. Third one also is an invalid code. Now decoding that prefix code, let us consider that we are having a code 10111110 and 0. So this will be my S0, 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 S1, S2 and S3. So let me decode it. By the Craft inequality, we write this decimation tree for the code 2 that was given. How do I write? See, for the S0, this is the initial state where we will start. For S0, what is the value of S0 here? It is 0. So move here, it is 0. Now for the S1, what is S1? It is 1 and 0. Initial state, it comes down, it moves here. So it is 1 and 0. Next for the S2, what? 1, 1, 0. Here initial state, this is 1, this is another 1, this is 0. So 1, 1, 0. Next for the S3, it is 1, 1, 1. So it is 1, 1, 1. So this is how we decode the prefix code. Next comes the Huffman coding, an important class of the prefix code. Inside the prefix code, this is a part. Okay, you need to know this is a very important topic. Sometimes they might ask you to write the algorithm also, or they may ask you any questions related to this Huffman coding. It's an algorithm. Here, source symbol is listed in the decreasing probability order. You need to note this. Two symbols of the lowest probability are assigned, that is 0 and 1. In this stage is called as a splitting stage. Next, these are the two source symbols that are combined into a new source symbol. That two which is having the lowest probability are combined with their probabilities to form a new source symbol. So that's sum of the two original probabilities. Next is procedure. This procedure gets repeated. A unit we are left with the final list of source symbol of only 2. Until we are left out with 2, we need to carry out which symbol 0, 1 are arranged. Now the code for each symbol is found by working backward and tracking. The sequence of zeros and ones are assigned to that of the symbol as well as to its successors. So let us see an example here. Here Huffman tree. Symbol S0, S1, S2, S3, S4 with the probabilities given like this. So higher probability means they are having short code word, lower probability means long code word. So this is a code word that gets coded to this. You can observe the Huffman length. What is the length here? 1, 2, 1, 2, 1, 2. Here it is 3. So it is 3. Now we'll start with the symbol. The symbols we have written in the stage 1, write down as it is probability what they have given in the decreasing order. Do note that you need to write it in the decreasing order. If you are not doing in the decreasing order, the entire problem that you are solving goes wrong. So here 0.1, 0.1 is the least. combine those two and keep it in the above place than the 0.2. So 0.2 it gets here. So again write down as it is. 0.4 is greater than 0.0, so it goes up and these two goes down. Now combine 0.2 and 0.2 and what happens? Adding these two we get 0.4. That goes to the top of the 0.4. Again write down as usual what is left out. Now what 0.4 and 0.4 get added and then that goes as 0.6. Then 0.4 comes down. So after writing this you just mark it as 1 and 0, 1 and 0, 1 and 0, 1 and 0. Finally, 0.4 plus 0.6 we get 1.0. So now we need to find the average code word. Let us move on to that. Here, the L bar it is equal to summation of Pi into Li. So what is Pi? Pi is nothing but the probabilities that are being given to us. Now what is the length here? Length, as I said, the code word that has been coded here. That is 0010. That is how did you get that is. So here for the 0.4 you can observe it is 1 0. So here you get it as 0 0. And next here you can observe that it is 1 and 0. So here it is 1. So it is 1 and 0. And for the another 0.2 it is 1 and 1. For the 0.1 it is, you can observe this gets a value of 1 0. So here it is 0 1 0. For the 0.1 it is 0 1 1. So by this length you need to substitute those lengths here and you will get the L bar as 2.2 binary symbol. Next, finding the entropy of that equation, find with along with the formula and the probabilities, find it out, and hence you can write it as h of s is less than L is less than h of s plus 1. So this is optimal solution. So let's move on to some of the questions. An information source produces a sequence of independent symbols having the following probabilities. That is, these are the probabilities. Now you just write down them in the decreasing order. You need to note that this is not in the decreasing order. You need to change this in the decreasing order. And finally, here you can observe the stage 1. This 2 gets added and you get it as 2 by 27. Again, now these 2 gets added and that becomes 1 by 9. And again this 1 by 9 gets added to 2 by 9. 2 by 9 and 1 by 9 get added to 1 by 3. And 1 by 3 and 1 by 3 gets added to 2 by 3. And finally, the 2 by 3 and 1 by 3 gets added as 1. So it is 0, 1. So here, what is the value? It is having 1. So this goes 1 here. And for this, for what value we are having here? 0. So this is 0 and 0. So similarly continue here. So what is 1 by 3 is having? 1 by 3 is having 0 0 and this is having 1 0. Finally, what is here? Here we are having 1, it is 0 1 and 1 1. So next we will carry out here. Here it is 0 0 only, here it is 1 0 only, here it is 1 1, and for this 0 and 1 what we are having? We are having 0 1 0 1. Similarly carry over here 0 0 1 0 1 1 and here we are having 0 1 and for this we are having 1 1 and 1 1. Continue it here. So as I said, what we got 0 0, we got 1 0. For this we have got for 1 by 9 we got 0 0 1 and for this it is 1 0 1 and finally again this goes to here, it is 0. So 0 0 1 1 and here what do we get? 0 1 1 and this 1 1 1 goes here as 1 by 27. So this is how we got this code. Writing this code is the main important part in this Huffman coding, and after writing that you need to find the efficiency find using this formula. For that you need to find h of s, entropy using this formula, then L bar using this formula. Therefore you get the efficiency and find out the redundancy.